Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Can you all hear me? See my slide? Okay, all right, thank you. Okay, it's already 8:30, so let's start our session today. I think can we start with the sharing the news or updates or any information from the five students that we've agreed last week? Check my list. Anyone want to go first?
I go first.
Ken.
Okay.
Okay, Faridul. All yours.
Everyone can see?
Yes, Ken.
Okay. It's about Honda plan to stop the combustion engine in 2000, 2040, which is a plan to build a full electric car in the future. They said the automaker will eliminate all production internal combustion engine, which plan all electric car by 2040, which is they have still enjoy uh, which gasoline car, but they also want to eliminate all the gasoline engine by 2040, and they also said will build a high quality with battery long lasting, which is using the GM battery techs, which are more powerful than other. That's it that I get from the Honda news to build electric by 2040, which is eliminate all the gasoline car.
I think that's the latest news. I think a few days ago.
Yes,
Right?
latest news.
Yeah, 2040. By that time pun saya dah pension. So, okay. Okay, thank you, Faridul.
Okay.
Who's next? Anyone?
Saya
Siapa?
Nick.
Nick. Okay, Nick. Mr.
Okay.
Nick.
Nampak.
Nampak.
Okay. Okay. Article that I found is about South Korea launches research on clean energy source for ICE. So South Korea, they launched like a research team to research about alternative fuel for ICE. So the alternative fuel is called electrofuel, which is produced by synthesizing hydrogen and other gases. So with the development of electrofuel, so ICE, internal combustion engine, can contribute to carbon neutral to reduce carbon emission. So not just by ditching the ICE, but we also include internal combustion engine in order to reduce carbon emission. That's South Korea plan. That's all from me.
I think the electrofuel ni is under the general term as synthetic fuel. I think.
Synthetic.
Right, Nick? Okay, thank you, Mr. Nick. Next, Afdal, Kamarul, Zulhilmi.
I go first.
Okay.
See my screen.
Yes, can. But you need to speak louder. Tak dengar.
Oh, okay.
Alright.
Dengar tak? Dengar. Okay.
Dengar.
And this article is about diesel engines. The technology, this article talk about a technology which using a supercharger as a blower to promote cleaner combustion. Uh, we know that diesel engines generate high temperature in the combustion chamber, which will produce more nitrogen oxide. And this new system combines a mini burn roots type blower, and the blower pumps air through the cold thermal unit start burner, which will inject and burn small amount of fuel into the airstream and quickly heating the catalyst. And once the catalyst reach about 200 to 250 degrees Celsius, it can efficiently convert nitrogen oxide to harmless nitrogen and water. Uh, and they claim that this new blower system could help manufacturers achieve Euro 7 nitrogen oxide reductions of 90%. That's all.
Okay, Abdul, thank you very much. That's very interesting. I think what Abdul punya info ni is more towards the what they call as cold start strategy. I think cold start is one of the most challenge criteria to meet the certain regulations or legislation. So by doing this method ni is basically they could actually shorten the warming up time so that the catalyst can be warm as quickly as possible. Right, Abdul?
Betul? Jadi
Okay.
cakap.
Yep.
Okay.
Thank you, Abdul.
Thank you, sir.
Okay, who's next?
Betul, dia macam dia tak baca.
Yes, Doctor.
Okay, Kamaru, Mr. Kamaru.
Okay. Okay, can you see?
Can.
Okay, today I want to share an article about Toyota is developing hydrogen combustion engines for racing. So instead of fuel cells, Toyota is developing a combustion engine that runs on hydrogen and not for daily road use. This time it's for racing. So as you can see, they are testing on scheduled for May 21 to 23rd. The car equipped with 1.6 liter turbocharged inline 3 engine on a Toyota Corolla Sport that using compressed hydrogen gas. They claim that hydrogen combustion had better responsive than liquid gasoline. All this idea is new, but most automakers want to avoid to the new calculation for the efficiency, carbon footprint, and also emission. Okay, that's all from me.
Okay, thank you, Kamaru. Very interesting. And I think through motorsport platform, manufacturers are trying many ways of trying to different types of approach and method through motorsport. I think there's no regulation, so they can actually develop so many things. Sport. Okay. Who's next? Last.
Hayrutul.
Siapa tu?
Zul Hilmi.
Zul. Okay, Zul. Okay, Mr. Zul.
You can see my screen?
Yes, can.
Alright. So Mitsubishi conduct combustion test for hydrogen engine with pure hydrogen. Joint project with AIST, which is a National Institute of Advanced Industrial Science and Technology, to achieve stable combustion of 100% hydrogen fuel for carbon free. So currently Mitsubishi do research about to identify the condition to achieve stable combustion of 100% hydrogen without emitting carbon oxide CO2. That's all what I read.
Okay, thank you, Zaimi. Thank you for highlighting about Mitsubishi. For your information, for everyone your information, Mitsubishi Heavy Industries do come to UTM to conduct their testings on their turbocharger with Lukatic. So Mitsubishi does have a relationship with UTM. So some of their turbocharger products were actually commissioned for UTM to test. Just in case you all don't know lah on that one. It's been like probably it's already 5 years and still they do send over some of their products to UTM for us to validate their turbochargers and compressors. Okay, thank you very much everyone. Towards the end of this session, I'll choose another 5. But let us start on today's session first. Put my screen up. Okay, just before I start, have you all got the solution of the solution that I made on for the exercise that I gave you 2 weeks ago? Okay, all right. Okay, if there's any questions on the solution, do email me or WhatsApp me. I can, if you do have any problems understanding the solution. But no worries, because as we move along, I will give you more exercises for you to practice. But let us move on to our chapter for today, which is chapter 6, which is the intake and fuel injection system. Just before we go on, just to remind you, so your tests will be conducted on 10th of May at 8:30 p.m. It's an open book test, okay? It's an open book test, but you are not allowed to copy lah, okay? So it will be 1.5 hour. Chapters covered will be from chapter 1 to chapter 4. Okay. If you ask me which chapter 4, which is the thermodynamic analysis, so definitely thermodynamic analysis will be included in your test on 10th of May. Okay. So on the 10th of May, we won't have any classes. Instead, we will conduct the test. Okay. So just a week before Raya lah. It's just nice. Okay, let's move on first. But if you have any questions on the test, you can ask me later. So on this chapter is broken down into 2 sections, which is the intake system and also the fuel injection system. Okay. So let's go on the intake system first. Okay. So the intake system is to deliver, the main purpose of the intake system is to deliver the proper amount of air and also fuel to all cylinders, okay, at a proper time, okay. If you're talking about direct injection engines, the intake system only delivers air. But for normal port fuel injection system, okay, it is a mixture of air and also fuel, okay. So the flow into engine is pulse as the intake valves open and close. Okay. And conventional air intake system consists of 4 main parts. Okay. Which is the intake manifold. Okay. The throttle body valve, the intake valves, and also the fuel injector. So these are the main components. Of course, air box as air snorkel is also included. But these are the 4 main part under the intake system. The intake manifold basically distributes the air into each of the cylinder. okay, is usually made of, nowadays is usually made of ABS plastic. Those days were actually made of cast alloy. Okay, and throttle body valves are actually the regulators which is connected to your accelerator pedal. Those days, these throttle body or throttle valves are actually connected using cables, okay, mechanical cables. But nowadays, most of the throttle body or throttle valves are actually electronic operated. Okay, so you can see that some of the term used by some manufacturers, they call it drive by wire. So the term drive by wire explains the uh, control of the throttle body valve using a motorized system. Okay, so there's no cable. Okay, these days most of the cars nowadays are actually operated by electronic throttle body. Intake valve basically is situated in the cylinder head. Okay, the intake valve basically opens and close according to the proper timing, depending on your cycle and so forth. Okay, fuel injector is basically as simple as spraying fuel, either through the uh, intake runners or in port fuel injection engines, or through the direct into the combustion chamber on direct injection engines. So those are the four main parts. This picture is basically, I purposely choose this picture because you can clearly see the components. So you can have, if you can imagine, this is a typical conventional engine. Okay. So you can see as the air, if you look at this particular picture, at the air filter somewhere down here, probably. So as the air goes past by the air filter, will go through the throttle valve or throttle body, which is situated here, and directly into the intake manifold. Okay. So fuel injectors are actually located on the intake manifold. And so this is a conventional port fuel injection engine. Okay. So that's just a picture for you to give some idea. Okay. So for the intake manifold, basically it consists of intake runners. Okay. It is the pipes from so throttle body is usually located at one end of the plenum. Okay. Uh, this volume is what you call as plenum lah. Yeah? So from this volume, it is being distributed to each of the cylinder. So most manufacturers, they try to design the try to design the intake manifold with equal distribution of the runner length. Okay, this is what you call as runner length. Okay, uh, and in some cars, these intake manifolds are actually heated. Okay, purposely heated for the purpose of evaporating the fuel. Okay. So you can see that this intake manifold, this is where the surface of where it is connected to your cylinder head. So intake diameter, which is the cross section of the intake manifold, it must be large enough, okay, large enough to reduce flow resistance, okay, but it cannot be too large. It needs to be small enough to ensure that the velocity of the air is high, and to produce turbulence to keep fuel droplets from falling out. Okay. And then, of course, because the intake runners or the intake manifold runners needs to be equal for the purpose to have an equal distribution of air between the cylinders. Okay. So that is basically on the intake manifold. So early evaporation reduces water efficiency due to fuel vapor displacing air. Okay. Fuel flows through manifold via fuel vapor mixed with air. Okay. This is when fuel is being injected as the air stream pass through the intake manifold. Liquid fuel droplets flowing into air and liquid fuel flowing along the wall. So those are some of the behavior of how the liquid is being mixed. Fuel is being mixed with the air. So large fuel droplets don't follow air around corners. So as much as possible, they try to minimize the fuel droplets. This is actually being controlled by the fuel injector, okay, and also the fuel pressure as well. Okay. Fuel composition differs between cylinder as well as air fuel ratio. So you can never ever achieve equal balance of how much fuel is being distributed. Therefore, your air fuel ratio between the cylinders also varies. Okay, slightly varies. Okay, you can never get a very accurate distribution between the cylinders. If fuel is vaporized too late, then small percent of high molecule weight fuel may not vaporize and stay on cylinder walls going into water. Okay. So if the vaporization of fuel is too late, then there's a possibility that small percentage of high molecule weight may not vaporize and stay on the cylinder walls. So as the fuel droplets, okay, in the liquid state presence in the cylinder wall, it will definitely flow down into pass through the piston rings and drop in the oil sump and mix with the engine oil. So that is not good. Okay? Which is why, as much as possible, we try to minimize the fuel in the liquid state. Okay, as much as possible, we want to have it in a vapor state. So this is basically some of the work from manufacturers. What they're trying to do over here is just a sample of how they would design the intake manifold to make sure that the intake runners are in the equal length. But of course, if you can imagine, as the air passes through here, through the throttle body. So if you look at the length as the air, let's say this is the starting point of if you want to measure the speed of the air and also the travel of the air. So as the air travels through cylinder number one, for example, it is much more shorter than compared to when the air needs to travel to the cylinder four. But of course, as much as possible, you try to make sure that, which is why some of the engines, they are locating the throttle body probably somewhere in the middle or something, like for example over here. Okay. So that is basically some of the things that they are doing in the effort to make sure that the distribution of air between the cylinders are equal. So let's talk about volumetric efficiency. Okay. So what is volumetric efficiency, or we call it as VE? So VE represents the efficiency of a compressed cylinder to compressed gas. Okay, it is the efficiency. Okay, it may be defined as the ratio of the volume of gas delivered to the piston displacement corrected to suction temperature and pressure. So if you look at the formula over here, the VE is calculated by the ratio between the how much air is filling in, the actual air that fills in the cylinder, and the ideal air that goes, or theoretical air that's supposed to fill in the cylinder. So of course, in actual, you cannot get 100. Okay, in certain cases, yes, but in actual, it's pretty much difficult to fill all the volume with air. So therefore, there might be some. So the amount of air that fills in the cylinder might be slightly lower than compared to the ideal, or how much air that's supposed to fill in the cylinder. So that is basically how you can calculate your volumetric efficiency. So you can see of how if you can fill in. So this is basically a good example of how you would determine a good VE. So if you manage to get in 40% of the air into the cylinder, you can see that the how much air is 40, the volumetric efficiency is only 40%. In most cases, natural aspirated engines, you would manage to get close to 100% efficiency. But on turbocharged engines, it shouldn't be any problem because you have the compressor to force or to push the air into the combustion chamber to fill in the volume. So on not natural aspirated engines, the highest you can get in actual probably probably it's it's 100%, but in forced induction engines through superchargers and also turbochargers, you can get VE above 100%. Probably looking at between 130 to 160%. Yeah. So in other words, why VE is so important? Because the more air that you fill in into the cylinder, the higher the VE. Okay, the higher the percentage of the VE. With higher VE, you get more power produced. Okay, so that is why reason why VE is really important for spark ignition engines, particularly. So VE less than 100% is one of the main reason is because due to vaporized fuel displacing air. Multi-port injector engines reduces vaporization and increase volumetric efficiency. Alcohols with higher air-fuel ratio have a greater volumetric efficiency losses. Okay, because the fact that it is not as because the fact that when you compare with normal gasoline, alcohols do have a better vaporization. Gaseous fuels, natural gas will have lower volumetric efficiency due to fully vaporized fuel. Okay, manifold heat should be also be eliminated in gasolines and also natural gas fuels. So this is just to show you some of the concepts or theories of how fuel can actually affect your volumetric efficiency. So at lower speed, as low engine speed increases, the air fuel temperature also increases due to larger resident time. Okay, because the fact that your mean piston speed is much lower, so the gases in your combustion chamber stays there much more longer. Okay, and also valve timing optimized at only one speed. Okay, this is in the case of where you have a fixed variable valve timing. But in the case of where you have a variable valve timing, then you should be able to manipulate the opening and closing of the valves to have a higher volumetric efficiency. Higher engine speed increases pressure loss in manifold and valves. Okay. Yes. Okay. So you shouldn't have any problems on volumetric efficiency as the engine speed increases. But at certain time, at certain speed, at certain values, as the volumetric efficiency reaches its peak value, it will start to go back down. Okay, this is because the movement of the pistons and valves is too quick for the movement of the air. Okay, so that's why you can have that's why the volumetric efficiency starts to decreases at certain piston speed. But of course, different engines has different characteristics, different values, but overall, the overall characteristics of the volumetric efficiency profile would be like that. If I can imagine, if I can exaggerate. But in the case of where for forced induction engines, you shouldn't have any problems or issues on volumetric efficiency because it is all boosted. So you can actually manipulate your VE to any value that you want because with the assistance of a compressor or supercharger. So flow is pulsating from zero to max flow rate at valve. Pressure wave is created that is reflected at the upstream end. Pressure waves can be reinforced or cancelled depending on frequency of the pulsation and runner length. Runner length can be tuned for pressure wave reinforcement, increasing volumetric efficiency at only one speed lah. Okay, which is why some of the engines are actually tuned or developed to cater certain engine speeds. Okay, most passenger cars, most of the time, volumetric efficiency are actually tuned from at lower to medium range engine speed. Whereas for competitions or race cars, usually they are tuned to have the VE at higher engine speeds. So it depends. Okay. Active intake systems can also assist. You have the variable intake manifold and so forth, so that you can actually change your runner length. And this is also useful for you to increase your volumetric efficiency. You can see through the popular ones is basically Vanos from BMW, whereby the running length is can be varied lah, any value that they want. So at probably a certain engine speed, the runner length changes. At lower engine speed, the runner length usually change to a lot longer length, whereas at high engine speed, runner length are actually tuned at a lower length. So you have a shorter length. On the intake valves, okay, basically the popular ones, the conventional ones, right at the moment, most of the manufacturers, most of the cars are actually using is the cockpit valves design. It is a spring loaded, okay, and it is operated by camshaft, okay. There are some engines which is operated through actuators and motorized, but it's very very few. But I can say that I think 80% or probably I can say 90% of the cars on the road right now is actually operated by camshafts. So ideally instantaneous opening and close. So practically significant opening and close over considerable crankshaft rotation. So the puppet valves are actually must also be designed to make sure that it prevents valve bouncing, okay, and also to prevent valve floating. So valve bouncing is basically when you have both of valve bouncing and also valve floating is an effect of where you are operating the engine at very very high engine speeds. Okay, so bouncing is basically the effect of where the surface of the valve seats are actually hitting the cylinder head surface and bouncing back. Okay. Whereas valve float is basically whereby if the camshaft is turning at a very extreme speed, okay, rotational speed, because the fact that the springs are not stiff enough, so it wouldn't have a fast reaction time to close down the valve. So in other words, when the camshaft is operating at high RPM, it's basically the valve is basically it's just opening. It doesn't have sufficient time to close. Okay. So those are some of the problems. Okay. This is whereby for you to calculate the valve lift is basically the distance of the valve opens. Okay. Typically on automotive engines, on small engines, probably the opening might reach 5 millimeter, but on certain engine nowadays, it reaches up to probably 10 to 13 millimeter or probably more. So you can actually calculate your valve lift using uh, that rule. Okay. So valve seat angle is also important in flow restriction. So the valve seat angle is actually this angle. So this is actually very important to make sure that what is the characteristics of air that passes through the valve. Okay. So some are actually designed for the air to be tumble, whereas some seat angles are actually meant for turbulence. See that another important parameters in intake valve design is actually the discharge coefficient. So it is actually a ratio of actual flow area to flow passage area. So you can that as simple as that lah. So you can actually calculate your if you can actually calculate your discharge coefficient by using the area of the actual divided by the actual of the area of the passage. Okay. And minimum intake valve area. So this is basically a popular questions in your test and also exam where they will ask you what is the minimum intake valve area. So in order for you to calculate what is the minimum intake valve area, you need to use this formula. You can see that it actually depends on the piston speed, mean piston speed. Okay, so different speed has a different minimum intake valve area. Okay. Intake valve design also varies. It might vary from two valves per cylinder, four valves per cylinder, five valves per cylinder. I've seen six valves per cylinder. But most of the time nowadays, most automotive engines they are running either on four or five valves, four or five valves per cylinder. If it's four valves per cylinder, so that means two of it is on each side and two on the exhaust side, whereas on the five valves per cylinder, it's common to have three intakes rather than three exhausts. So you have three intakes and two exhausts. So I'll go through this one very quickly. Intake for two-stroke cycle. This is not much of it's not that important in this course, but nevertheless, it's good for you to also to know. Inlet air in two-stroke cycle engines must be input at a pressure greater than atmospheric. Following blowdown at the start of the intake process of the cylinder is still filled with exhaust gas atmospheric. There is no such thing as exhaust stroke. Take stroke cycle. Air under pressure enters the cylinder and pushes most of the remaining exhaust residual out the still open exhaust port. This is what they call as scavenging phenomena. Scavenging is very, very important in two-stroke cycle. I think we've gone through this in our previous chapter. When most of the exhaust gas is out, the exhaust port closes and the cylinder is filled with air. Okay. At part throttle, inlet pressure is low, and this resulting a poor scavenging. So these are some of the example of intake system in two-stroke cycle. The most common one we've seen, it's either the loop scavenge and also the uniflow scavenge. On the uniflow scavenge is the only approach that is using the exhaust bar. Okay, so we can just go through this. What is the some of the intake approach or intake system in between cross, loop, and also uniflow. Okay, any questions so far before we go into fuel injection system?
Question, doctor.
Okay. Can we take a break 5 minutes kejap tak?
Okay, sir. Okay, sir. Sure.
Okay. Okay, we'll take 5 minutes break sekejap sebab we'll see you back in 5 minutes. Thank you. Okay, shall we start?
Boleh. Kan Doktor?
All right. So let's finish this one quickly. Nothing much on the fuel injection system. This is more towards your understanding on what is the components, also sensors in the fuel injection system. So basically, a fuel injection system basically consists of a system by itself. Consists of fuel supply, or in other words, your fuel tank. Okay. Then there's most of the cars nowadays, they have a single pump. But those days are on certain high performance engines, they have two different pumps, which is a low pressure pump, and then you have a high pressure pump. Okay. So the fuel pump basically carries the fuel to the fuel rail through a fuel filter. Okay, and then the fuel rail basically holds the injectors and supply the fuel to each of the injectors. And towards the end, also in the injection system, you also have a fuel pressure regulator which controls the amount of pressure. Okay. And sometimes the fuel pressure regulator, I think most of the cars nowadays, fuel pressure regulator are actually located uh, immediately after the fuel pump. Okay, these days. But old days, old cars, or I would say those days, fuel pressure regulators are usually located next to the fuel rail. So that is a typical conventional fuel injection system. So you can see this is some of the artistic picture of how layout of the fuel rail and connected to the fuel injectors on each cylinder, and fuel is supplied to the fuel rail. So the purpose, let's go through very quickly on the fuel injectors. Basically, it sprays fuel directly into the air, either at the intake manifold for port fuel injection, or for direct injection engines. Fuel injectors are actually located to spray the fuel into the combustion chamber. And most of fuel injectors, either direct or port fuel, it is controlled through the engine management system or the ECU. Whereas on older engines, these injectors are actually mechanically controlled. So in a typical injector consists of needle, pintle, winding, and also connectors, which is connected to your engine management system. So this is just to show you a difference between electronic and mechanical injector. Okay. On electronic injector, it's using a solenoid base, whereas on mechanical injectors, it's using a plunger or a spring-loaded. Okay. So multi-port injector, most popular, the most popular ones is definitely the Bosch multi-port injection system. It sprays fuel on the back of the valve. Okay, this is on the case of port fuel injection. Okay, and by spraying the fuel at the back of the valves, when the valves are hot, it actually assists or helps the fuel to vaporize. Of course, these injectors need to be pressurized to ensure that the droplets of fuel is very small to augment the vaporization and therefore minimize air fuel ratio variation between the cylinders. So no carburetor venturi throat pressure drop. This is not relevant. This is if we want to compare with the carburetor system. In carburetor system, you don't have a fuel injection system. Okay, obviously. And large manifold runners can be used because air does not have to carry the fuel. So I've purposely not included carburetor over here because it is not relevant these days anymore. But those days, yes, before the fuel injection system was actually created, the fuel is actually supplied using carburetors. So this is just a typical layout of how the fuel is being injected. So as the air passes through the air filter, it will go through the throttle valve or throttle body, and it will go through as the air passes through the injector. The the injector will spray the fuel so that it is streamlined with the air and mix before it is actually entering the combustion chamber via the valves. Okay. So fuel quantity might vary by through controlling the injection timing. So you talk the fuel is being injected by the injector in each cycle varies, but most of the time it will be injected within the duration of between 1.5 to 10 milliseconds. So it's very small portion of time. Okay. So fuel quantity determined by the oxygen sensor for catalytic converter equipped engines. So this is basically based on the closed loop system. Okay. So in the case of whereby you have an engine with an oxygen sensor, it will determine whether how much air fuel ratio, whether it's richer or leaner. So the engine management system should be clever enough to determine to inject more or to reduce the fuel, so forth. Amount of fuel also varies. It also depends on the mapping or the calibration of the engine operation at different engine speed, different manifold vacuum, different throttle position, and also different air mass flow. So those are some of the parameters that actually affects how much fuel is being injected. Okay, it's not just based on one parameter, but you're looking at between 6 to 8 parameters. Okay, at one time. So airflow or air mass is measured. Okay, how much air is being entering the combustion chamber is actually measured either by using hot wire sensor. Okay, or or you can either determine how much air that goes into the combustion chamber by the manifold air pressure transducer. So on old engines, they would prefer to use hot wire. But nowadays, because engine management system are very complex and they have a high processing capabilities and so forth, so they are able to use manifold air pressure. The thing is with hot wire sensor, it's very expensive compared to manifold air pressure sensor or MAP sensor. So I think most of the cars nowadays are using manifold air pressure, but the setback about manifold air pressure is it is not as accurate as the hot wire sensor. But on high performance engine or luxury engines, they usually prefer to use hot wire because it's very accurate compared to manifold air pressure. But for low cost purposes, they would go for manifold air pressure. Some injection systems mix air with fuel. This also enhances the evaporation and also mixing between the air and also fuel. It is also used in two-stroke engines with shorter time for evaporation. Can use combustion cylinder pressure to drive injector and mix air. But the thing is with combustion cylinder pressure, it's very expensive, so it's not being included in production engines. On compression ignition engines or diesel engines, they are operated via unthrottle approach, where speed and power are actually controlled by how much fuel is being injected. Okay, so to improve thermal efficiency, where no restriction to flow as fuel added late in the compression stroke, so air enters alone into the induction system, and fuel is usually started. Fuel is actually injected at This is just a typical value, which is 20 degrees before TDC, and it ends about 5 degrees after TDC. So in total, you're looking at between 25 degrees of duration in terms of crank angle. But in terms of time, you're looking at between 1 to 1 point, probably 10 to 15 milliseconds. For CI engines, fuel injected directly into the combustion chamber. So this is the same case for direct injection engine as well. But for CI engine, it is relying on the SIT, and therefore it requires a very high compression, okay, in order for to start the combustion before TDC. Fuel injection continues and combustion proceeds well in power stroke. Injection pressure must be high enough to admit fuel against the high pressure of the compression stroke. Those are some of the rules for CI engines. So during injection, okay, either through CI or SI, doesn't matter. The mass flow of rate fuel through an injector can be calculated using that formula based on the discharge coefficient of the injector. Okay, the flow area of the nozzle, density of the fuel used, okay, and also pressure difference across injectors. So this is basically the pressure before and after the winding of the injector. So this figure is just to show you how much, what is the duration of fuel compared to air in terms of crank angle. So you can see that in terms of crank angle, this is actually the air that enters the combustion chamber. Okay, but in terms of crank angle, the fuel is only 1/5 portion of the total opening time for the air to enter the combustion chamber. So it's quite a very short duration. Okay. Some advantages of fuel injection system, operational benefits to the driver of a fuel injected car include, of course, it's much more smoother because it is controlled by the engine management system. It's clever enough, and it's more responsive with quick throttle transitions because the fact that the fuel is actually controlled, electronically controlled. Okay, easier and more dependable engine starting. So this is what relates to the cold starting strategy. So under cold weather or cold conditions, the engine knows that how much fuel must be used in order to have a very smooth operation during cold weather. Okay. Better operation at extremely high and low ambient temperatures. Yes, this is basically vice versa with the cold conditions. So engine management system should be clever enough to identify this. Increased maintenance intervals, yes. With the fuel injection system, there's hardly thing for you to maintain compared to a carburetor. Okay, because it's quite straightforward. The only thing that you need to maintain is mainly on the fuel pump, fuel filter, and also the injector itself. But definitely the maintenance intervals is there, but definitely it's much more longer compared to carburetor. On a more basic level, fuel injection system does away with choke. Okay, so on fuel injection system, as I said, engine management system is clever enough, so you don't need a manual choke like the carburetor. Instead, the issue should be clever enough to determine all the situations or conditions in order for the engine operate at a operate smoothly. So these are some of the main sensors under the fuel injection system. And this list is basically just a definition for you. It's good that you know that these sensors, so these are some of the minimum requirement sensors or commonly used in vehicles under the injection systems. We have the mass airflow sensor. As I said, mass airflow sensor can be the hot wire or can be in a map manifold pressure sensor, either one. You have the oxygen sensor, or sometimes we call it O2 sensor. Okay, and you have the throttle position sensor. This is to know what is the opening of the valve in the throttle body. Okay, you have the coolant temperature sensor to identify whether the condition is cold or is it hot. Voltage sensor just to make sure that the voltage is sufficient to supply sufficient voltage is supplied to all the components. And then you have the manifold absolute pressure or the MAP sensor. Yes, this is the quite similar to this is basically another option from the hot wire mass airflow sensor. Engine speed sensor is the sensor that detects the engine speed or engine RPM. Okay, so these are some of the locations on it. But I'm sure you can you get a better understanding by going to or Google. So some of the locations, battery relay sets, ECU, coil, air measuring instrument, supplementary air valve, throttle switch, temperature sensor. Those are some of the other components under the fuel injection system. These as well: cold starting solenoid injector, delay thermal switch, fuel pressure regulator, fuel delivery line, excess fuel exhaust line, ignition switch, etc., etc. Okay, that's pretty much under what you have in chapter 6, which consists of intake system and also the fuel injection system. Is there any question?
I have a question, sir.
Yes. Okay.
Um, I'm just actually wondering on a typical car, how many ECU does a car have actually? We know that they have a engine ECU, and then we got to know that there's also a ABS and ECS ECU or something. So actually, how many ECUs are there in a car?
It depends. If you talk about normally, usually they have 3 ECUs for different purposes. One is just to control on the powertrain system, which you usually call as ECU, engine control unit. The other one is the transmission ECU, okay, because transmission has a different ECU. And then the third one is basically you have the chassis ECU. So this chassis ECU responsible for the ABS, traction control, and so forth. But as I said, different cars has a different strategy. Some developers, manufacturers, they would develop everything into a single ECU. Some manufacturers, they combine the engine and also the transmission into one ECU and keep the chassis into a separate ECU, or they can have separate ECUs and so forth. So it might vary from one vehicle to another. But you might asking why they can't just create one ECU, right? It's because engine usually developed by another party. Transmission is developed by another party, and the other components such as the ABS system, the traction control, is developed by another party. So each of the party has a different issues and so forth. So it's just imagine if your engine is actually the engine management system or ECU is developed by Bosch, for example, and transmission is being developed by Extract, for example. So different manufacturers has a different issues, but what they did instead of combining the issue, because they definitely they do want to share what are the content of their issue. So what they did is try to produce a common language, okay, electronic signal language, or sometimes they call it as CAN high, CAN low, or CAN bus, which they can actually interpret those language into a common language so that they could understand between each other. But yeah, if coming back to the question today, yes, some cars they have most cars I know they have two issues. The engine and also the engine issue and also the transmission issue. So, but if the chassis like such as the ABS or the traction control is so complex, then they would definitely need a processing unit. So in order for them to have a processing unit, definitely they need a, 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 a dedicated issue for that. Does that answer your question?
Yes, sir. I was quite wondering as to we difficultly understand that there is a issue for the engine, but it's just that I got to know about the transmission and the chassis just now.
Yeah, I
Okay.
think yeah. Because okay, automatic transmission is not so complex. Okay, but if you're talking about CVT, then definitely if you're talking about CVT, then definitely it requires a TCU, transmission control unit.
Oh, it's called TCU.
But
Okay.
if the automatic transmission is very complex, such as the you're looking at between if it's a 4-speed automatic transmission, is quite straightforward. It's quite simple. But if talking about 980, 980, 780, 9-speed transmission, automatic transmission, then definitely it requires a special control unit, which they call as TCU.
Okay, sir. That's it. That's the only question I have.
Okay. Any more question?
Assalamualaikum.
Salam.
Okay. One question. How about canvas system, Doctor, in a car that we have in modern cars? Is does that mean like what Fahim has said earlier? Um, if I rephrase back, his question is about how many ECU that we have in a car, but in a canvas system, is the ECU is connected um to the car itself? I mean, to the all the sensors around the car, or is it just only in the engine management?
It's connected. So if you definitely the TCU needs to talk to the ECU needs to talk to the to the chassis issue. So it's like which is why because the fact that they need to talk to each other, which is why Canvas is the best language for them to use.
So that means the ECU is also connected to the network, lah.
Yes, because yes, it's all connected because the fact that they want to make sure that the whole vehicle is clever enough to detect if there's any to detect the environment so that the ECU transmission and also chassis uh, can do certain actions together as a whole system.
Mm-hmm. Alright. And then second question is like, how about standalone ECU? Okay, if we use a standalone ECU and we tune it on our own, tune it by our own, does that mean we can get better fuel economy or better power than a standard ECU, or the standard ECU itself is the best solution for the engine?
Okay, okay. That's a good question. Some vehicles, yes, you can get better. Some vehicles, no. First of all, you need to understand that once you take out any, okay, if you take out a sensor in the transmission, the issue will know, even though it's different control unit. So, which is why if you put in a standalone, which is a foreigner control unit, into the system, the transmission control unit wouldn't understand the language that this standalone issue is communicating. So that is one challenge lah. But definitely, if you talk about
Again, doktor tadi tadi macam putus-putus.
oh, okay. If you put in a standalone issue, it's like a foreigner. Okay. So definitely the TCU cannot basically understand the communication with the new partner, the new standalone issue, because when they develop the cars, the TCU issue developers have shared information. Okay, we're gonna talk in this language. There are several binary codes that they've understood. So they know that certain languages, certain signals is common between them. But when you replace your new issue, standalone issue, which is not which is different from what they've understood between the original issue and the TCU, so that will cause a problem for your TCU lah. But in terms of whether, if you coming back to the question whether you can get better fuel economy, yes, because certain cars are actually purposely developed for performance, for example. And when they are concentrating on the performance, probably they are sacrificing on the fuel economy, and probably in certain cases whereby they purposely concentrate fuel economy at certain region of the engine speed, for example. Whereas, but in reality, you don't actually drive within that region, right? So by having a standalone issue, yes, you can actually there's a luxury for you to actually cater towards your own needs, because manufacturers, they try to develop a car which is like in general good for everyone. But for standalone issues, you can actually cater towards your preference, your personal preference and so forth. So that would definitely benefit you, but might not benefit others lah.
And then touching on the subject that doctor said about the transmission control unit, but if I use a manual gearbox, then that means the TCU problem we can eliminate lah kan?
Yes, correct.
So that means if I drive a manual, it's better for me to have a standalone ECU lah for
Yes,
to
yes, correct.
optimize.
So,
Yes,
so there is
but
an advantage of a manual car lah.
but this one tak masuk lagi. We haven't considered the chassis issue, which is the traction control, the
Okay.
the ABS and so forth. Because remember, all of the TCU are actually communicating. So even though if you have a manual engine, okay, manual sensor, a manual transmission, you might need to figure out what about the ABS, traction control. So if for this is, we're talking about the modern cars nowadays. Those days, if you're talking about 20, 30 years ago, vehicles from 20, 30 years ago, you shouldn't have any problem at all. Or probably if you buy a car now, modern cars nowadays, but it's very simple. So there are cars in the mid-90s whereby the engine doesn't talk to your transmission and it doesn't talk to your chassis. But now, in today's car, they are all talking to each other.
Okay, can understand that.
Just to share a couple of years ago, we did a test whereby we bought what car was that? That was a Ford Focus. We wanted to test the Ford Focus engine into a dynamometer bench, okay, the dyno bench, okay. So this is whereby we need to bring the engine into the dyno bench, okay, just the engine. and we tried to use the standard wirings and harness on the engine control unit ECU, and the car cannot start at all. There's no modifications. We took out the exact components, the whole engine system, and we took out the wiring harness, and we used all back the standard ECU into the dyno, and the car wouldn't start, cannot start at all. Do you know why? We after a month, we noticed that the ECU requires a sensor, the ABS sensor to work. So that's one thing lah. So that shows that the plus plus after we solve it, we cannot run the engine above 2000 rpm. Then only we found out that the meter panel needs to be connected. So that is just one example to show that now today's cars, they need everything to be in perfect condition. You took out one part, surprisingly, the whole car shuts down.
Why, doctor? Is it because of safety or is it because of?
I think it's because of they want to make sure that the intelligence of the control unit to they want the control unit to be very intelligent. They want to develop a control unit that actually that actually understands and aware of your environmental conditions. So on those days whereby when they develop engines, most of the sensors are actually concerned over engine operation only. But nowadays it has to be more than that. So the engine needs to operate based on, for example, what is the environment? How does the transmission how does the transmission operates? How does the ABS operates? Does the traction control operates? In certain engines, certain vehicles, I think in BMW, I think if your there's something wrong in your traction control, you cannot rev the engine above 3000. So that's just one example why do they go for this approach.
But then mesti dia ada kekurangan dia, the cons where I think because they make the engine less less independent, more dependent on other sensors. Does that mean that it will, break all the time? Is it because why continental cars are, not cheap to maintain?
Yeah, I think in a way, yes, you are right. Those are the challenges lah. But but hardly I think because if sensors break down, it's pretty much nowadays in modern cars, if there's any wrong with your sensor, it's pretty much easy to detect using onboard diagnostic tools. So they are not worried about the sensors. They are more concerned on whether the engine or the whole vehicle performs in terms of fuel economy, performance, emission, and so forth. And of course, in terms of safety as well.
I see.
But I think you cannot run away from having some of the some of the small components breaking down. It affects the whole vehicle. Yes, that you cannot run away from that.
Because I think because my uncle actually owns a W124 Mercedes, the the E-Class from 1980s, I think. And then he said that if there's even like any sensors that are broken or something, then the car won't, you know, it will start, but it will have problems running perfectly.
Yeah. I think there's some limitations. I think different manufacturers have the different strategies and so forth. yeah, I think like I know certain cars they probably they allow if depends on the critical of the sensor lah. If for example if the speed sensor if the ABS doesn't work then it's very critical, right? Because it affects your safety can. It depends.
So our
If
okay.
if the sensor is not that critical, then you might just check. You might just get a warning light, right?
Mhm. But how about our local cars, sir? Are they dependent on other sensors too, as much as the Germans
Sorry,
German car?
sorry. Can you repeat the question? Tak dengar. Sorry.
Okay, hello.
Yeah.
How about local cars, Doctor? Are there our are their engine management system dependent on other non-engine punya sensors on the newer
Local.
ones?
The newer ones, I'm not so sure. I don't know about the X50, X70, or the new Azia on that. But anything previous than that model, not that critical.
Mm-hmm.
So not that critical. So if the traction control doesn't work, it might just come out with a warning check light or something like that. But not sure on the models above 2020. I'm not sure on that.
Right. Okay, thank you, Doctor.
Okay, thank you very much. Okay, just before we finish ni, I just wanna highlight you all, okay, give you the attendance sekejap. So, in the chat box, there's the attendance link and also a reminder for your test. So your test will be on the 10th of May, 8:30 to 10 p.m. It's a open book test, but you are not allowed to copy or discuss, okay? But it's an open book test, so you can refer to any books or you can open your internet whatsoever, but you cannot refer to your friend, okay? Chapter 1 to chapter 4 only. Okay, so it will be on synchronized mode in test 1, whereby you need to you need to be online. Okay, and then you need to finish the questions within the time given and submit your answer sheet. You can either take a picture of it and save it as a PDF and put it into a Google link, which I will provide later. Is there any question on test 1?
How many questions, sir?
Most likely between 3 to 4 questions. Through 3 to 4 big questions.
Okay. Are there any contoh soalan or past years that Doctor
Okay,
have that can share?
the thing is the previous I haven't figured out because the fact that previously the test is actually done in physical mode. And it's a closed book test. So this is the first time I'm writing it in as an open book test. So I can share you the closed book test punya questions later.
Right. Okay. I think if Doctor can share through e-learning, that would be
Can I'll share in e-learning.
okay.
Okay.
Doctor,
Okay. Yes.
about the test, uh, we have we sort of have a tablet that we can write on, sort of like a paper. Would that be okay for you?
Yeah. Can.
Okay.
And any form of writing, either on paper, piece of paper, or electronic, as long as I can read, shouldn't be any problem.
Okay. Thank you. That'll be all.
The only thing you cannot do is refer to your friend or copy from your friend. That's the only thing you cannot do. Is
Okay.
that clear?
Clear.
You can refer to internet, you can refer to your notes or textbook, doesn't really matter. But you cannot ask your friend.
Okay, sir.
I would to done that. Other than that. Okay. Oh yeah, I need to choose another 5. Apa lah belum? Amsyah siapa? Amsyah? Are you there?
Saya ada.
Amsyah boleh kan next week?
Boleh.
Alright. Amsyah. Sekejap. Yasir. Yasir dah. Are you there, Yasir?
Yasir pergi toilet je.
Pergi toilet, okay. Okay, kejap tengok nama. Siapa lagi belum? Siapa nak volunteer sebelum saya pilih ni? Lagi cepat, lagi bagus. Kita boleh habis. Siapa belum?
Saya nak pilih Yasir, nanti saya beritahu dia.
Okay. Siapa lagi belum?
Saya belum lagi, sir.
Siapa tu?
Azmi.
Azmi. Mr. Azmi next week boleh Azmi?
Boleh, doktor.
Shaharia, are you there? Mr. Shahar? It's okay, tak apa. I will go through the list and I will pass you the list those yang belum. I will pass it to Daniel. Probably Daniel can inform others lah. I'll go through it.
Okay.
Okay, everyone. Thank you very much for your attendance and attention. I'll see you next week. Take care. Anything? If you have any questions, do email me regarding the exercise. I'll see you next week. Take
Alright.
care. Selamat berpuasa to everyone.
Alright,
Assalamualaikum
thank you,
warahmatullahi wabarakatuh.
Thank you, doktor.
Thank
Okay,
you, Doctor.
welcome.